Solve for x problems containing square roots. Right, now this is something that I've seen quite a bit with matriculants, but this is something that I think most grade 11s will also appreciate. Is how to solve problems when I've got a square root involved, like this. And what to do, solve for x if there's a square root involved. And the most important thing that I really want you to take away from this is that when I solve a problem containing a square root, I'm going to square to get rid of the square root first. And secondly, when I square to get rid of the square root, you must check for your answers, right? You must check your answers at the end. You must go and test them, put them back in the original equation and see if they work, because some of them won't, right? And this is mainly because, say for instance, my answer was actually what I wanted was -3, right? So I gave it to you as -√9. Right now, the moment in somewhere in with a square root, right? But now, if you go and square this thing, it becomes 9, right? And actually, if you think about the square root of 9, it can actually be +3 or -3. And if I was thinking of the number -3 and I give it hidden in a problem to you, and you squared it working with 9, by the end when you solve the problem for x, well, you're not sure whether x should now be -3 or +3, and to know whether it's -3 or +3, you actually need to go check whatever answer you get into the original equation to check which one works. Because if I was thinking of -√3, and I hid it somewhere in an equation, it might actually give a different effect than +3 in the same equation, right? So you need to go check your answer. That's the important thing that I want you to take away from this video. Right, so let's quickly see. This was a question in a question paper where this is two functions, x minus 4, which is a straight line, of course, and √2x, which the grade 11s won't know that, but the grade 12s might notice that this is an inverse function of a parabola. It is a root function and it looks like that. But you usually just draw 1/2 of it to still keep it a function. But okay, but that is a function that looks something like that. And they didn't ask you to draw it though. They gave you these two functions and they said determine the intercept between these two graphs. Okay, now to determine an intercept, I want to solve simultaneously for h and g. Which both of these are in the form y is equal to x minus 4 and y is equal to 2x. So I can literally just make the two y's equal to one another, meaning I'm just going to simply set these two equations equal to one another, which is fairly easy, right? Now, when solving an equation like this with a root in it, I want to get the root alone. In this question, the root is alone. But if there was, for instance, a +1 there, I will take the +1 over so that I've got the root alone. And then after I've got the root alone, then what I will do is I will just square both sides and then I'm rid of the root. Ta-da! Okay, that's quite easy. Right, so x minus 4 squared, I'm going to literally take x minus 4 times x minus 4. And √2x squared, the root and the square just cancel one another out, so that looks like that. And this I'm just going to quickly multiply out, minus 4x minus 4x and plus 16. Hopefully you are more than capable to do that. Right, and then I'm going to take the 2x over, so this becomes 10x. And now I've got a basic standard quadratic equation, and if I factorize that, also hopefully you can do that, but if you can't, there is a video on this channel under basic principles where I show you in detailed steps how to factorize. So if you're unsure of that, or there's still things that you're wondering, there is a video on this channel. Go and check that out. And then I've got two solutions for x, which is 8 and 2. Right, now I squared, so I must go and test my answers. Right, so if I've got this left-hand side is x minus 4 and the right-hand side is root 2x, I'm first just going to test for x is equal to 8. So that will be x minus 4, which is 8 now. 4, that's that side, and the right hand side was root 2x, which is root of 2 times 8, which is root 16, and that's 4, so this is fine. Right, it gives me the same thing. Let's quickly check for x is equal to 2. So I've got x minus 4, which is 2 minus 4, and that gives me minus 2. And if I've got root of 2x, I've got root of 2 times 2, and that gives me root 4, which is 2, and this is not fine. Right, these two things should be the same, and they're not. Right, so this answer is not valid. And then I just have that x is equal to 8. All right, and since in this particular question I actually wanted the coordinate pair of the intersection between these two graphs, I actually substituted 8 in there and calculated y is 4. They wanted the intercept between these graphs, and in a coordinate pair that would be the point 8, 4, which is then an intersection of this graph. Right. So now I just literally want to go through a few problems. So this is the concept that I just wanted to show to you. Be careful that that's not something that you make a mistake in. And I'm now just quickly gonna work through some problems containing a root. This is fairly easy one. To just show you what to do with roots and how to tackle things with roots and show you some funny things. The basic thing that I told you in the previous one is if you've got a root in a problem, you want to get it alone, right? So take that 3 over and then just square both sides. So I've got 2x plus 1 and I square this, giving me 9. Now if I square, I must go and test my answer. Right, here I can already tell you it's not going to be a problem because this is a positive root and this is a positive 3 and I squared them, so it's not going to give me any problems. But just to be safe, I'm still going to test this answer. Right, so I've got x is 4, and if I substitute that in there, I get, this is 8 plus 1 is 9, so root of 9 is 3, minus 3 is 0. Right, now you might ask, why is it not plus minus the root? Because you know from grade 11 and 12, if there's a root, it can be positive or negative. Right, ma'am, now why is this not positive or negative root? That's just if I write x, you assume it's positive. If I write minus x, then you know it's negative. If there's nothing in front, then you assume it's a positive x, right? And this is not a root that you took. It was a root that was given to you, and then there's nothing in front, so this is a positive root, right? But if you take a root, if you've got x squared is 9 and you go take a root, then you have to put a plus minus in front. right? But this root, you didn't take it, it was given to you and it's positive, right? So then you assume it's positive unless there's a negative in front of it. Okay, right. So this answer works, it's perfectly fine, so that's an answer, right? Then let's quickly look at this one. Because now I've told you, so now I'm just going to show you a few things that doesn't work exactly like I told you. Now you get the root alone and you square, but here is now 3 roots. Now how do I get this alone? Because if I square this side, it's fine, it's just going to give me x, but if I square this, I have to take root 32 plus root 18 times root 32 plus root 18, and this is gonna be one heck of a calculation. You're welcome to do that, but this is gonna be one heck of a calculation to do, right? But whenever you work with numbers in square roots and in exponents and you don't know what to do, the best thing to do 99% of the time is get the prime factor form of the numbers, right? By prime factor form, I mean that thing that you did in primary school, this thing, you divide by prime factors. So 2, I divide by prime factors until I can't divide by 2 anymore, then I go to 3, 5, 7, etc. So 32, I'm going to write in prime factor form as 2 to the power of 5, and 18, I'm going to write in prime factor form as 2 times 3 squared. Right. Now, if you have this specific Casio FX82 model, this model can do this. Then you don't need to go and do it by hand like I did it here. If you have any other calculator, unfortunately, you have to do it like this, how I did it here, right? But if you have this calculator, let me just quickly show you. There, above that button, it says fact, right, on the calculator itself, just above that button. So you press shift fact to get the prime factor form. Just important, if I say want to get 32, I must press equal first so that I've got 32 there, and then I press shift fact, and then it gives me 2 to the power of 5. And if I press 18 equal first, shift fact, it gives me 2 times 3 squared, right? But this is the only model calculator. There's also a gray one and a blue one that I've seen that the children use. They can also do it, the gray one, the blue one, and this one, but this specific Casio model is the only calculator on the market that I know of that can do this prime factor form. Otherwise, if you've got like a shop or something, you've got to have to do it like this. Right. Okay, so now I'm just going to take out here the 2 to the power of 5. The 2 to the power of 4, I'm actually going to take out because root of 2 to the power of 4 is 2 squared, which is 4. I don't actually need to write that. And then that 1, 2 that was still left, the fifth one, I'm just going to leave under the root, right? And also 3 squared, the root of 3 squared is just 3, but that 2, I'm just going to leave under the root like that. And then I can add these two guys together. Like you would say 4x plus 3x is 7x. I'm going to say 4 root 2 plus 3 root 2 is 7 root 2. Right? And so you see this question is a bit different than that one because you actually have to manipulate this part a little bit until you get one root on each side, and then you can just square. Then it's a lot less messier than it would have been to just multiply these two with one another. So if I square, this side becomes x, and this side square both of these things becomes 49. Don't leave the 7, square the 7 and square the square root 2 becomes 2. And then 49 times 2 is 98, but I'm just going to check. Yep. Okay, so x is 98. Right, and then you can check with your calculator. Actually, root of 98 is 7 root 2. Yes, okay. I'm just going to test, although if you get one answer, usually that one answer is fine. But if you get two answers, you need to go check them. All right. So I'm testing root of 98 is 7 root 2, and I'm also going to just check root 32 plus root 18 is also 7 root 2, and the right hand side is also 7 root 2. Right, so this answer is absolutely fine. Okay, let's quickly do one last question here, which is also now something, this is quite an interesting question. I love stuff like this. I love it. Okay, this is a beautiful, beautiful question. Right, now you can go and get this root alone. You're more than welcome to do that. That method would have worked absolutely fine. So I take the 10 over and I take the x over, and then I square both sides. So this becomes 9 root x. 9x, sorry. I square the minus 3, it becomes 9. I square the root, it becomes x. And then if I square this, I must actually go and I can't just say 100 minus x squared because there's a plus or a minus. I must actually go and square it like this, right? And then I'm left with minus 20x plus x squared. I'm left with a quadratic equation. I'm just going to reorganize it a little bit and take this one over. 29x plus 100. Okay. And this is going to factorize into, you can actually go and list all of the factors of 100, but it's going to take you a while. I just saw 25 times 4 is 100 and it gives me 29. So 25 times 4, this is 0 now. So x is equal to 25, or x is equal to 4. And then you must go check your answer. But I just want to show you there's another method of doing this that's going to be much shorter, right? Remember I had x is 25 or x is 4. Okay. 25 and 4. Have you got that? Right. Can you see that this looks like a quadratic equation, x squared minus 3x minus 10? Apart from the fact that instead of an x squared, I've got an x, the root of that. And instead of an x, I've got a root x, the root of that, right? So this is like a quadratic equation. Instead of x, I've got root x. So if I factorize this into, if it was an x squared and an x, just ignore that for a second, I would factorize it into x minus 5 plus 3, yes, minus 5x plus 3x, no, plus 2x, I'm lying, minus 5x plus 2x, and minus 10 and x squared, right? But now to fix this, I must just put roots over both these x's, because instead of an x, I've got a root x in here. So from that, I've got root x is equal to 5, or root x is equal to minus 2. And if I square both sides, I've got x is 25, or x is 4. This is just so much easier than the previous method. But that's the beauty of math, is you've got one method that works for everything, and then you've got these brilliant methods that doesn't work for everything, but it makes it so much shorter. But if you can solve the same problem in 4 different methods, then you've really got that problem down. So it's always good to try and solve problems in more than one way, right? So now I'm going to test this because I squared there and there. I'm just going to test this answers. Okay, so if I've got x is equal to 25, I've got 25 minus 3 root 25 minus 10, and that gives me 25 minus, this is 5, right? So I've got 3 times 5 is 15 minus 10, and this is going to be 25 minus 15 is 10 minus 10 is 0, and that is perfectly fine. It should give me 0. Right, and then I'm going to test x is equal to 4. So I've got 4 minus 3 root 4 minus 10 is equal to, no, I want to test whether it comes to 0, so I'm not going to say it is 0 at the moment. So I've got 4 minus 3 times 2, which is 6. Root 4 is 2, yes. And then 4 minus 6 is minus 2 minus 10 is minus 12, which is not 0. So this answer is not valid. It doesn't work out. Right. So then I can just say, perfectly fine, I'm happy with x is 25. Right, and I hope this really sets you a little bit more at ease with working with square roots while solving for x.